I'm Melanie Bell, president of the Cheney-Spokane chapter of the Ice Age Floods Institute. Dr. Gary Ford, your lecturer tonight, is the current president of the Ice Age Floods Institute, and he's been that now for 8 years. More than 20 years ago, he read about the Great Missoula floods and began attending lectures and field trips and reading books and publications and so forth. So he's going to share with you tonight some highlights that he figured out about the flood story. I also want you to know that this presentation is being recorded and will be up on YouTube in about a week. And we have information out on the website or you can search IceAgeFloods-Cheney-Spokane on YouTube and share this with your friends and family and watch it again if you would like. So that's a real treat for us to be able to see Dr. Ford's presentation. So I present to you Dr. Gary Ford.
Okay, Melanie, thank you very much. I asked Melanie to keep the introduction short, and for her, that is short. All right, we'll get going here. For something getting close now to the last 100 years, there's been a lot of people working to figure out the flood story. And it's really interesting to me. I looked more recently at a couple of Geological Society of America guidebooks that were produced in the relatively last few years. One of them had 145 references. The other one had 268. So hopefully that gives you a sense that this flood story is, it's big and it's complicated, and for a whole lot of us, it's just incredibly fascinating. And it's so fascinating, in fact, that the Institute has 11 chapters and over 700 members, all who think the flood story is pretty darn fascinating. All right, so I'm going to amend what Melanie said just a tad, in that what I'm going to be sharing is, for the biggest part of the presentation, is we're going to take a look at 6 common questions that people ask about the floods. And we'll be looking at, for each one of those, how the people who study these things for a living have figured that out. And so this isn't about me figuring these things out, but it's about me and other of our members learning from the people who have figured them out. Okay, I like to, in a presentation like this, you never know for sure how familiar the people in your audience are with the flood story. So it's worthwhile to spend just a couple of minutes on some basic orientation. This is a great map, one of the best products that the Institute has put together. It's available from the Institute store. You can see the website information here at the top. So just a few highlights. These are things that we'll be talking about as we go through the presentation. We're talking about, of course, Western Montana, North Idaho, Washington, basically east of the Cascades, then down through the gorge, Willamette Valley, and finally out to the ocean. So And a little more detail, when you look at this area in western Montana, the area in blue is Glacial Lake Missoula, which was created when the Purcell lobe of ice came down from the north. Another blue area over in here, Glacial Lake Columbia, that was created when the Okanagan lobe of ice came down from the north. And then you can see all of these dark colored areas running across a lot of the map. These are the flood pathways. That's where the various floods went at different times. So hopefully, if you're new to all this, that helps a little bit. Well, before we get into taking a look at those questions that are commonly asked, you really have to back up just a little bit and try to understand how this process of figuring things out started. And most people, if they don't know a whole lot about the floods, they know about this guy, J. Harlan Bretz. He showed up in the Northwest around 1908. He was a high school science teacher, graduate student, professor at the University of Washington for a year. Then from 1915 to the 60s, he was at the University of Chicago as a professor and researcher on Ice Age floods and other topics. So it all starts with Bretz. Now, the interesting thing about it, it was in the summer of 1922, kind of late in the summer, when Bretz and his students first started poking around in eastern Washington. And when he did that, he saw some areas that he thought he understood how they might have formed, but he also saw a whole lot of other areas that were pretty puzzling to him. Now, it's important to remember that this was before aerial photographs, satellite images, that kind of stuff. And his observations were based on lots of actual field work. This is a great picture from the internet. It shows J. Harlan Bretz here and three of his graduate students that came along as his field assistants. In the early 20s, they all came out from Chicago on the train. And then when they got out here, this Thomas Large that it refers to in the caption apparently made it possible for Bretz to get transportation with this Model T. Well, I always wondered, 100 years ago, what was it like when all of these people, Bretz and his crew, were out doing field work? What was field work like in the 1920s? And I found this wonderful brief description in the book Bretz's Flood, which we'll talk about a little later on. It describes the field work in 1923. And it says, trekking across its expanse on foot with his three graduate students, they would camp wherever they happened to be when the sun set at the end of each day. They also made use of a number of railroad lines that crossed the vast and largely empty spaces of the scablands. Disembarking trains, they explored thousands of square miles on foot for days, heading for other train stops whenever they needed to go into one small town or another for food, baths, and a few well-deserved mugs of beer. Well, I love that description that John Sonicson did in his book. It gives you a sense of what the work was like back then. And one of the reasons for wanting to share this with you is that sometimes we can look at the results of all that work and not necessarily appreciate everything that goes into doing the work. Okay, so when Bretz started looking around there towards the end of the summer in 1922, he saw some areas that I think he was pretty familiar with. You know, the Palouse with the rolling loess hills. Loess landscapes are pretty common around the world. There's a bunch of them in the Midwest. So I think Bretz probably didn't even slow down much when he looked at these. Now, on the other hand, he saw a lot of other things that were really puzzling to him. And we're just going to look at a half a dozen or so, but the amount of things that he worked with and observed was phenomenal. But the idea is this mystery of what caused all of these landscape features wound up sort of dominating a big chunk of his life for years and years. And initially in the 1920s, they came out like for 7 years mapping these areas and trying to understand them. And of course, this is what at least now we call a loess island. This is the stuff that the Palouse consists of, but you can see that there's just sort of a remnant here of the loess surrounded by a bunch of the black basalt that occurs underneath it. So I'm sure when Bretz started looking at this stuff, he thought, what happened to the loess? What removed it? Where did it go? And I need to point out also, as we're looking at these, that these are examples are taken from the air. And so things are more obvious where, again, when Bretz was first working with all this stuff and looking at it, he was walking around on the ground. So here's a case of, you know, basalt flows are normally somewhat uniform anyway, but you can look at the top of this basalt and see there all kinds of it's been removed. So that, again, another mystery. What removed those chunks of basalt and most of the loess that was once on top of them? Okay, another different type of feature, but these are large valleys called coulees locally, and it sure looked like it was formed somewhere along the line, maybe by some kind of running water, but there isn't any water in there now to speak of, and certainly no water body that's big enough to create something like that. So again, how did these form? There were certain areas also, a pretty spectacular example, one of them where you have these big cliffs, these steep, what are called cataracts. And at the bottom here is this large plunge pool, normally formed by a whole lot of water pouring into it. But here, clearly, this huge plunge pool was not created by the small river. So again, what caused this? You can just imagine Bretz's brain humming as he's looking at all this stuff and trying to make sense of it. Another classic example, again, another one from the air, these huge cataracts that go for miles. And yet when you look around, there's no river coming through there that would create the cataract or some of these plunge pools. So what created this? Another question for Bretz and his field assistants. This is also another example. The bulk of the Columbia Basin is black basalt. And yet when you're out there looking around, you can see in some cases some really big white rocks on and near the surface of the soil. And this occurs in areas way south of where the glaciers were. So it's not like the glacier came down and dropped these. So how did they get there? Okay, so that's just a few examples of the kind of things that Bretz and his crew observed. So for 7 years in the 1920s, Bretz and his field assistants mapped thousands of acres of what he called the channeled scablands. And he published 11 scientific papers on this work from 1923 to 1932. Now, he referred to the events that occurred out here in the channel scablands as the Spokane floods. This is a map of Bretz's from 1923, and I know you can't see the detail. I just want you to look at this and kind of remember what the pattern looks like. Spokane is here, the Tri-Cities down here, and the Columbia River's over here. But just remember what that pattern looks like, because we're going to come back to another one later on, another example of looking at that same pattern. Okay, so this is, I think this photo was taken later in the 20s because by then Bretz had his own car. That's the one in front, the covered sedan. So he was able to drive out from Chicago. But I wanted to make the point that for people who are unfamiliar with Bretz, that he was a very good field geologist who carefully studied and tested the evidence before making interpretations. He was not a man that was prone to impulsive conclusions or all kinds of speculation. So after spending that 7 years mapping all of that country, and when you look through a lot of his papers, it's hard to find a place in the scablands that Bretz didn't go to and write up. So, but when he looked at all of the evidence that was there, he believed that the only explanation that made sense to him was that it had to have been created by a cataclysmic flood. Now, early on, he didn't know where the water came from, but he believed the evidence spoke for itself. And he knew this was a highly controversial conclusion he knew would be challenged. So basically in about 1932 or so, Bretz went back to Chicago and started working on other things. He said there by the early 30s, he had looked at all the evidence, he'd written it all up, and it was time for him to do something else. And he hoped that during the intervening time that more people would go out to the scablands, look for themselves, and look at the evidence and see what they thought about it. So one thing that some people are not aware of, because most of the time they think Bretz whole life was the scablands, but in fact, when he left there in the early 1930s, for about the next 20 years, he did other things. He studied about 100 caves in 17 states, Mexico and Bermuda, made a trip to Greenland. He studied Glacial Lake Chicago, which was a predecessor of Lake Michigan, and I'm sure he did other things as well. But one of the things then that slowly began to happen while Bretz was off studying these other things is we had new research, new technology came along, which helped bring about the acceptance of his ideas. And there were also more people coming to the area to see what Bretz was talking about. There for a while, the Depression was on, World War II, and people weren't traveling a whole lot. So it took a while before people started getting back out or getting to this area for the first time to look around. So finally, in the 1950s, the Bureau of Reclamation had a big Columbia Basin irrigation project. Grand Coulee Dam had been built, and now they were focusing on how to get the water to the farmers so they could use it. So in the course of that project, they assembled all kinds of new maps, aerial photos, soil surveys, and other landscape information that was not previously available. Well, this information finally brought Bretz back to the scablands in 1952, and it resulted in one of his last major papers, 82 pages long. And it's interesting, I read this quote from Richard Waite, one of the USGS researchers in this Field Guide 15, who described Bretz's 1952 paper. He said it utterly refutes the rival hypotheses and so vindicates Bretz's great flood theory as to end scientific opposition. So a very, very major paper that Bretz put together in the mid-50s. Another thing that finally happened, Bretz starting to get more acceptance of his ideas. This is sort of a famous event where 1965, a team of experts came out and looked at all the Glacial Lake Missoula stuff and then the scabland. And by the time they were done, they sent Bretz a long telegram, which ended with, "We are all catastrophists." Okay, one of the other things that then finally happens later on because of all the new technologies, the satellite imagery. And if you look sort of in the middle part of this, which is surrounded by a lot of snow, why you can see a pattern that's very reminiscent of Bretz's 1923 map. And so this again is an example of some of that stuff that took a long time to figure out when you had to do it on the ground. Suddenly, when this new imagery comes along, the landscape patterns associated with the floods just jumped out immediately at everyone who looked at it. Okay, since we're going to be talking about other stuff here in a bit and not going to spend a lot more time on Bretz, I wanted to push you, for those of you who would like more information, we have a couple of books I'm going to refer you to that are available from the store. a good book in 2008 by John Sonicson on Bretz's flood, and it's very readable and has lots of good personal information on J. Harlan Bretz. If you haven't read it, it's worth a shot. Another good book that came out about a year after that, this one was an update, and principal author was Scott Burns from Portland State. The thing that's really good about this, in addition to being an updated book on the floods, is he has some sections that discuss the controversy in more detail and the people advocating other points of view. So if you're interested, his book is a good place to go for that. The other thing that I really appreciated Scott Burns doing in this book is he had a section, a book, the chapter I think is something like Major Researchers Since Bretz. And he identifies, I think, like 28 people who have continued to work on the flood story beyond Bretz. So again, that's a good book to read, and it's available from the store. So this is a expression that I've heard before. I think the first time was about Sir Isaac Newton, but standing on the shoulders of giants refers to the fact that most progress in science is done building on the work of others. And with the flood story, why obviously J. Harlan Bretz's work has been the foundation that researchers have been building on since that last publication in the mid-50s. And because the work has continued, researchers have made new discoveries, and the floods continue to be a subject of debate. These new discoveries find their way into the literature and are tested and refined by others, such as the nature of science. Okay, so that was sort of some general background stuff. So the remainder of the presentation, we're going to briefly address these 6 questions. And I say at the beginning up here that there is not universal agreement on some of these things that I'll talk about. In other words, this is science. There's lots of ideas about things, not universal agreement all that often. And so you can consider the things that I'm going to talk about here and the findings to be sort of, this is the current thinking by, let's say, the majority of people dealing with some of these things. All right, so the 6 questions, and then these are some of the general things that our members ask about the floods when they're first learning about a lot of this. So one basic question is, how do we know there was a huge glacial lake in western Montana? How do we know it drained rapidly? How many floods were there? Where did the floodwater come from? How do we determine the age of the floods deposits? And then the last one, how long did it take the floodwater to move through the various pathways and eventually get to the ocean? All right, so now we're going to tackle those 6 questions one at a time and kind of briefly. So how do we know there was a huge glacial lake in western Montana? Well, most of you, if you've been involved much at all on the floods, it usually starts with a picture from the Missoula Valley showing the ancient shorelines of Glacial Lake Missoula. The thing that I found really interesting in preparing for this presentation was that the discovery, the first person to, in writing, to identify these as old lake shorelines was a pretty prominent geologist of the time, T.C. Chamberlain, and he made his observations 135 years ago. So some of this, has been known for a while, at least as isolated pieces of information. So, okay, so there was the big glacial lake there, according to Chamberlain. And the first effort to, in a scientific paper to talk about Glacial Lake Missoula was in 1910 by a fellow by the name of Joseph Pardee that we'll talk about several times during the presentation. But his paper was the first effort to document that in recent times there was a big ice dam lake filled a large part of the Clark Fork River drainage basin there in northwest Montana. So this is when it started to show up in the literature, Geology 1910. Now, Pardee described those ancient shorelines up to 4,200 feet in elevation. He gave Chamberlain credit for the discovery, as well as his tentative suggestion that the ice dam was in the Pardee area of Idaho with outflow by way of Spokane. So again, this is back 1910, turn of the century, that sort of thing. And so people were starting to put together, to connect some of the dots, if you will, about the story. Now, part of the fun, to me, of studying the floods is learning what certain types of features look like in one place, perhaps on an institute field trip, and then looking for and finding those features in other places. Okay, so what do I mean by that? Well, you saw what the ancient shorelines looked like there in the Missoula Valley, but you can follow those, what are sometimes called bathtub rings, around much of the area where that blue area was shown on the map for Glacial Lake Missoula. You follow around in that area, you can see these ancient shorelines continuing from one area to the next. This was a great photograph the first time I saw it. This is up near the ice dam, Clark Fork, Idaho. And for a long time, you couldn't see much up there in terms of shorelines because it was very well forested. Well, back in the 1930s, there was a forest fire went through there, burned off the vegetation. And when it was open, you could see here's these same shorelines extending all the way from the Missoula Valley, all the way up to the ice dam. So a lot of this stuff you can see if you're out exploring. Here's another thing that you can look for is if you want to try to keep track of where that big glacial lake was, Glacial Lake Missoula, lake sediments look very different than the typical gravel, cobble, boulder sort of water deposits that you find associated with rivers. Here you're looking with something much, much finer, silts and clays and that kind of thing. And when you're driving over to Missoula, you'll go through a really big road cut, and you can see these things very well displayed. Now, right next to the freeway is not a good time to, or a good place to look at these, but you can get off of the freeway into the secondary roads, some of them that go above this cut, and you can find a safer place to look at this. But the idea being, okay, so this is kind of an interesting looking deposit. And then as you continue driving around western Montana, you can find other places exposed by the rivers or highways where you can see a lot of that same fine sediment. This looks a little different from the other place because you're more on the edge of Glacial Lake Missoula, but it's still the same very fine sediments. So you can follow Glacial Lake Missoula around quite a bit. If you get off of Interstate 90 and you head north towards Flathead Lake, this is another place where the road will take you right by some of those strange looking, they're very, very fine sediments. Again, deposited in very quiet water in a lake. Okay, so now we want to move on to question 2. So, okay, we know there was a big glacial lake there in western Montana, which held up to 520 cubic miles of water at maximum depth. But how do we know it drained rapidly? You know, in other words, it could have been a situation where the ice sort of slowly melted back and Glacial Lake Missoula sort of drained to the west. So how do we know that it in fact drained really rapidly? Well, the first evidence is a very famous site in the Camas Prairie, Marco Pass area of northwest Montana on the west side of Flathead Lake. And this information was generated by new research by that same Joseph Pardee who did the paper in 1910. Now he's 30 years further along in his career. He's getting about ready to retire. And he presented a really interesting paper at a meeting in Seattle on ripple marks, question mark, in Glacial Lake Missoula in Montana. One of the classic papers in studying the floods, and the actual paper was published a couple years later with a little different title. But Joseph Pardee, one of the key players in all of this, along with Bretz. So Bretz's discovery started when he obtained aerial photographs from the U.S. Forest Service. And he acknowledged in the paper that we'll get to in a minute that the evidence that he came up with would not have been possible if he hadn't been able to look at those areas with aerial photographs. You could walk around on the ground and walk over and around some of that stuff, but it wasn't readily apparent what you were looking at. So brings us back to something I think most of us know by now, that in studying the floods, there's no substitute for the big picture. So those aerial photographs were priceless. Okay, so this is a copy of one of the maps in his paper, And we'll look just briefly at this, and then we'll look at some aerial imagery of the same thing. But the map in his 1942 paper, he mapped a whole lot of these parallel features. You can see the lines going up through here over much of the area. Well, what Pardee found were giant current ripples and other features which he believed were formed by deep, fast-moving water. Now, most of us have seen ripples, either like on the coast or along your favorite body of water. And the size of the ripples depends mostly on the depth and the speed of the water. So here you can see what those parallel lines that were on Pardee's map look like when you can see them from the air and you begin to appreciate how huge they are and how so much of the area is covered with these giant current ripples. Another view of the ripples, a little closer to the ground, 13 to 50 feet high, the ripples, 200 to 500 feet apart. The lake in here, when it started draining rapidly in response to the ice dam failure, was initially 800 feet deep and moving 60 miles an hour. So a whole lot of water moving really rapidly to the west. Well, I think a fair amount of people have been exposed to the idea of those current ripples there at Camas Prairie and maybe know a little bit about them. But one of the things that makes it really important was that it's like a lot of other floods features that once you see something and you know what it is and what it looks like, then you start looking other places for the same thing. And in fact, the giant current ripples have been found at many other places, indicating deep, fast-moving water that flowed over much of the floods area. And it was the discovery of these giant current ripples more than any other piece of evidence that finally convinced many skeptics that Bretz was right about the floods, because these things are so big and obviously had to have been created by deep water moving really fast. Well, Vic Baker, a longtime floods researcher from the University of Arizona, in one of his papers, identified 60 major areas of giant current ripples, over 100 total sites. So again, the idea when you start looking at the scabland area, that 60 major areas have been found of the giant current ripples. This is one that we'll refer to a little later. This is the West Bar. It's adjacent to the Columbia River. Okay, so question 3. Hope you're all hanging in with me on this. I'm not being able to look out at everyone's smiling face has limitations. So this question of how many floods were there has been around a long time, certainly not resolved. But researchers have been working for many years trying to figure this out. Bretz originally thought there was only one flood. He later decided there were 6. And the number of floods has sort of fluctuated over the years as research has continued. Now, I put this picture of the Grand Canyon in here, one to see if anybody's paying attention. The other is to remind people that geologists studying the floods do not have the luxury of large, deep exposures like you would have at the Grand Canyon. Instead, they deal with a limited amount of exposures scattered across large areas. So that's part of the challenge of geology, is dealing with a limited amount of exposures of things and collecting the evidence and making sense out of it and drawing the best conclusions you can. So work by 2 USGS researchers, frequently quoted in the literature, say there were 89 to 95 floods during the most recent times. Brian Atwater in the mid-80s, working in the Sandpoil area of Glacial Lake, Columbia, thought there were 89. Richard Waite, he has done many papers in the 1980s and more recently worked in lots of different places. He worked in the Burlingame Canyon area, east of Wallua Gap, and other areas. And he tends to think there were 95 or more floods. Okay, this is an example. I thought it would be fun for people to get a little bit of a sense of some of the things you try to look at when you're doing this kind of work. We talked about before that sometimes there's limited exposures of the stuff you're trying to study. This is a case of, like, in the 1920s, there was a irrigation canal that broke, and you had a whole lot of water that went where it normally wouldn't go and created this Burlingame Canyon. It's like 100 feet deep and I don't know, 1,000 feet long or something like that. But it exposed all of these layers. So you can imagine what a wonderful surprise this was for the first geologists, or many geologists, who have gone there to take a look at this and try to figure out what they're looking at. Well, the flood exposure here, because of the irrigation canal rupturing, exposed 40 layers. They're called the rhythmites, tushy beds, that sort of thing. But each one of those, if you take a look at it, it has what they call graded beds. So the material tends to be coarse at the bottom and finer at the top. So it's kind of like when the flood water flows in, the coarse stuff settles out, and eventually the water goes back out, and the finer stuff is deposited on top of it. So the controversy for a while was looking at these 40 layers and saying, well, does each one of those layers represent a flood, or could a number of those have been deposited by the same flood? Well, Richard Waite, who has spent a lot of time studying this area, believes that each one of those rhythmites represents a separate flood from Glacial Lake Glacial Lake Missoula. And some of the evidence of that for believing that each one of those is the product of a separate flood is about between the 11th and 12th layer down. I don't know exactly where that is, someplace in here we'll say. He found a couple thin layers of Mount St. Helens ash. And we'll talk about ash a little bit more in a minute, but each of those ash falls is a very diagnostic signature, and so you can identify which ash fall you're dealing with. And this one was from what's called Mount St. Helens S, and it's aged at about 15,400 years old. And what that meant was the place where the ash was found, the layers below that were older than that. The layers above it were younger. Now, the other evidence that helped Waite decide that each one of these was a separate flood was that there were a number of places apparently where at the top of a particular layer, such as the volcanic ash was found in one case, but there was other places where there would be evidence of plant and animal activity, showing that that area had been out of the water and an upland site long enough for biological activity to occur. All right, well, hopefully that's not too much deal for you, but it gives you some sense again of the kinds of things you have to look at when you're trying to date some of these things. Question 4, where do the scabland floods come from? This is a DSA field guide map from number 49 that Richard Waite put together, and it shows 3 areas on here that there is evidence of the floods. And so, of course, the big one over western Montana that we've talked all about, Glacial Lake Missoula. We know that that ice dam came down from the north, failed a number of times, and all of that water from Glacial Lake Missoula flowed at one time or another through all of these pathways that are shown on the map in kind of the brown color. And exactly where the floods went in any given time depended upon how big the flood was and whether this Okanagan Glacier was down here damming things up or not. The second area is about the time, well, back up just a little bit. Most of the floods from Glacial Lake Missoula, at least one big one came through before Glacial Lake Columbia was here, but most of them, the Missoula floods came over here, flowed into Glacial Lake Columbia, and then on towards the ocean. Eventually, the ice retreated enough. Glacial Lake Missoula was no more. Glacial Lake Columbia lasted for a couple of decades or a couple centuries perhaps after that, and then eventually there were a couple of floods from Glacial Lake Columbia as well, and one of them being that area along the Columbia River that we looked at a little while ago, West Bar. And then finally, the other area, and this is one more recently that Richard Waite has found evidence for, is that as the Purcell Trench was retreating into Canada, it dammed up another lake called Glacial Lake Kootenai, and the water from that got into the upper part of the Columbia and flowed for some distance down. So those are the three areas that there is evidence for. I went backwards. Okay, question 5, an interesting one. How do we determine the age of flood deposits? Well, the methodology depends on the age of the deposit. While most flood sediments we talk about are relatively young, some areas of much older flood deposits have also been found. And what that means is that the total number of floods that have occurred is much, much more than the 89 to 95 plus ones that some researchers believe occurred most recently. So a lot of floods have gone through the area, some of them more recently, some of them a lot older. So given that differences in ages, how do you age these things? Well, the big thing is you have to get lucky and find something you can date, which is easier said than done. And so, and generally you're looking for something that's organic in nature, wood, bones, seeds, mammoth tusks, shells, peat. And if you can find something organic, you can carbon-14 date it. The other thing that you're looking for is the volcanic ash. And we've talked about one of these layers, the Mount St. Helens S ash, which is typically found between floods deposits. You'll also find a deposit from Glacier Peak, which was significantly younger than Mount St. Helens, and that's found normally on top of the floods layers. So the dating process then consists of taking the samples that have been found, and they all have, plus or minus standard deviations and all that kind of stuff, and a lot of variability and not very many samples. But having considered all of that, the younger floods are commonly estimated to have occurred between 18,000 years ago and 15,000 years ago. Okay, how about those older floods? Well, kind of interesting, a review by one of Scott Burns's graduate students did a master's thesis back in 2012, Erica Metley, and she documented 25 areas of flood deposits older than the Missoula floods. So again, we spent a lot of time talking about mostly the Missoula floods, but there's been a whole lot more activity going on out there on the landscape. It's just that a lot of those areas have been buried or materials been washed away, or other things have happened. So here, okay, how do we know we're dealing with old flood deposits? Well, there's 3 things that you can look for. One is highly weathered soils. It takes a long time and the right kind of conditions to weather a soil. Another one is the presence of thick, white, caliche, or hardpan layers. This is my favorite, because when you're out there driving around in the scabland areas, start paying attention to road cuts. And this is one of the things that's relatively easy to spot. It'll be, like I say, you're looking for something that's thick, really white, and if you can go up and peck away at it a little bit, it's hard as all get out. So that's another caliche layers especially thick ones, take a long time to form. So that's a tip that you're probably dealing with something much older. And then if you think you're dealing with something older, then occasionally people check on the polarity of the deposits. And the idea here is that the Earth's poles shift periodically. Sometimes it's so-called normal polarity, other times reverse polarity. So let's look at an example of that. This is from Revere, Washington, and this is a field trip. This is Gene Cheever here in the blue shirt, khaki pants, I think, that walking up to the exposure, so you can get a sort of an idea of the scale here. But this had, I think, some more recent busts on top, and then you get into material here, some of the white layers that you can see that stand out probably the most is some of the caliche, and these are buried soils that are over 780,000 years old. And underneath it, there's some even older flood deposits. So again, a lot of things have happened out there on these landscapes. Okay, we're coming up on the last question. Hope you're all hanging in there with me. So one of the other questions that comes up a lot is, how long did it take the flood water to move through the entire area and reach the ocean? So in other words, when the ice dam failed here in northern Idaho, and all of this flood water started pouring out of there, how long did it take for the water to get through all these pathways and all the way out to the ocean? Well, of course, nobody knows for sure. And so the way you try to answer this is by modeling it. And the modeling of something like this is incredibly complex and sophisticated, but here are some considerations. There were perhaps, like you say, maybe 90 or 100 floods, whatever, but no two of those floods were exactly the same. Some were big, some were small, some flowed without any diversion through the area. Others ran into Glacial Lake Columbia, and then the Okanagan lobe, and got diverted. So there's a lot of things that you have to decide how you want to model it before you do all this. And so this particular case, which was in the GSA bulletin back in 2010, they used a large but not the largest flood. And they assumed that there was the damming of the Columbia River by the Okanagan lobe. And this was so big that it took like 250 days of computer time for one full model run. So a lot of complexity. All right, so what were the results of their simulation? What did they say? How long did it take for things to happen? And I've got a bunch of abbreviations in here, and I apologize for, but a lot of information in a short amount of room. But so Glacial Lake Missoula, in their modeling, they say drained in 2 days. So you're looking at 500 cubic miles of water, something on that order, draining in 2 days. The Cheni-Spokane tract area that's near and dear to our chapter area. It filled in about 24 hours, and all that water coming up out of Lake Missoula, going through here and coming down into the Cheni-Spokane tract pretty quick. And then it drained in about 55 hours, and where the Pasco Basin began draining in about 38 hours. But basically, you have to remember that what happened, all the water gets right down here at Wallua Gap, and it starts backing up big time because the constriction there is so narrow. So you get the water moving through the system pretty quickly, but then it's down there piling up, creating temporary Lake Lewis. And then like 3 weeks, they estimate for the water to get all through Wallua Gap, down through that narrow Columbia Gorge, and eventually find its way out to the ocean. So this is, I think, the last slide, and I want to leave you with an idea of some of the kinds of things you still have to figure out. They say we've looked at what a bunch of things have been figured out, or where they're at in figuring those things out. But this was a more recent modeling effort in 2017, where they tried 6 different scenarios of bringing the ice down and damming things up and trying to see what effect it had on water movement through the system. And their conclusion was really interesting. It says, these varied model scenarios illustrate that flooding from the gigantic Missoula floods does not reach maximum stage everywhere for any one scenario. Rather, different scenarios each produce different maximum stages in different places and provide a focus for future field studies. So what that means is, you know, with decades of geologists have mapped where the floods went out there, in terms of where the boundaries were, especially the high water mark in all these areas. What's the highest level that the floods were? So now when you're trying to model these things, it's that actual field evidence that you use to validate your model. And what they tried to do here was find a scenario where a certain set of given conditions would meet all the high water levels all the way through the scablands. And they didn't find one. Meaning, of course, that the whole drainage pattern and all of that is a lot more complicated than that, and that there was not one flood. At least so far, they haven't found a scenario that hits all of the high water marks at the same time. All right, well, I hope you're all still with me, and I hope you had some fun learning how some of these things have been figuring out, and there's lots more work to be done. All right, I am done, and we'll be happy to try to entertain some questions.
So Gary, thank you very much. This was very informative, and it's really great to see these great slides that you have that you've provided as well. So I had several inquiries while you were on, even a FaceTime session, asking about, they had trouble getting in, and wanted to know if it was recording, and I said we would be recording it. So this won't go away. We'll be able to provide it to the public. And we really appreciate your presentation and your time that you spent on this. And we will look forward to our October Zoom session with Bruce Mornstad. And thanks to everyone for joining us in tonight. And Chris, I'll let you close out however you want to close out.
Thanks, Melanie. Yeah,
Yep.
well, thank you so much for coming. And thank you, Dr. Gary. I really appreciate it. I wish we could hear everybody clapping like you would in a regular audience, but maybe we'll be able to join together and do that this next year when all this COVID stuff comes to an end. So we have the schedule up on the Ice Age Floods calendar, and we may be sending out some messages. It'll be a different Zoom link that next time, but it's in the calendar. The correct Zoom link is there, and you can add it to your calendar as well.
Okay, onward to the next Zoom.
All right.
Everybody have a good evening.
Thank you.
Bye.
Thank you.
Take care.